One edit distance. This is a premium medium problem, but this is actually is a very simple problem. But there is a catch. So given two strings s and t, return true if they are both one distance apart, one edit distance apart. Otherwise return false. And what do you mean by one distance apart? A string is said to be one distance apart from a string t if you can insert exactly one character into s to get t, delete one character from s to get t, or replace one character of s with a different character to get t. But you can just delete one character or insert one character or replace one character. Consider S is AB and T is ACB. That means we have to insert a character between A and B to make both similar, both same. Now, if S is ACB, T is AB, that means we have to delete this character C. If S is small a, T is capital A, that means we have to replace this character. Now you all know the edit distance problem, right? So given two strings, we have to return the minimum operations to make S and T equal, right? So that is a complex kind of dynamic programming based approach, but this is a very simple problem, and this is asked in companies like Meta, Amazon, Uber and all. So you have to think very simple, but also there is a catch. Consider this same problem, same example, AB and ACB, right? At index 1, these two characters are not same. That means we have three operations we can perform. If we want to insert, then between A and B we inserted C to match it with that. And in that case we have to match this part, rest of BS and rest of T, right? So index of S can remain same, but index of T will move one further. So we have to check for this part. S from I index equals to T from I plus 1 index. If you want to delete a character, let's say here B and C is not matching, so you want to delete this B. That means you have to check for this part. S from I plus 1, rest of the S, and T from this character only, because these two are not matching. I am just deleting character. I want to check for this part. If I want to replace the character A, B, A, C, B, B and C is not matching, I want to change B with C, right? Then that case we can check rest of the character for S and rest for T, right? So S from I plus 1 equals to T from I plus 1. So at any point if there is a mismatch, we can check for this three operation, these three conditions, and if any of these three returns true, we can say these two are one distance apart. But consider this problem here. The first character only mismatches. C and B is not matching. That means we have to do this insert, delete and replace three operations to check if it is satisfied, right? So in total there will be order of 3n operations. This is order of n only, but let's see if we can improve it further. So consider here S is AB, T is ACB. Here S is ACB, T is AB. The complete opposite here, right? So here in this case we have to insert one character between A and B, right? And do check accordingly. Here in this case we have to delete one character from S and we'll check accordingly. But you see both these operations are equivalent, because we just want to tell like if these two strings are one distance apart. We don't care whether we performed a insert operation or delete operation. We just need to tell this, right? So we can just get rid of one operation, either insert or delete we can take care of. But how do we do that? We have to fix some condition, some restrictions. Either length of S is less than length of T or length of S is greater than length of T, right? If length of S is less than length of T, means this kind of scenario, right? Otherwise we'll just change, swap S and T, to get this. Now, if length of s is less than length of t, that means two conditions can happen. Either they both are of same length, or length of s is 1 less than length of t. If this difference, length of t minus length of s, if this difference is greater than 1, that means you cannot perform one operation and make both equal, right? We can immediately return false. But this two set condition if satisfies, first, if both the length are same, that means when there is a mismatch in the strings, we have to replace the character, and we can check for replace condition. And if length of s is equals to 1 less than length of t, that means we have to insert one character, right? So we have to check for these two conditions, and the complexity will be order of n. First, let's take the length of this two string separately, ns and nt, that is length of s and length of t. If n length of s is greater than length of t, then I'm just swapping these two, or we can just call this separately, self dot ts, right? I'm just calling it in reverse order. Now I'll just go through the length of s for I in range ns. If s of I not equals to s of t of I, then there are two possibilities, right? Either we can insert or replace. If ns equals to nt, that means we are replacing the ith character, and we'll check for si plus 1, s from I plus 1 equals to t from I plus 1. Else we have to insert one thing, right? It's basically ns equals to nt minus 1 scenario. I have to return, we have to insert 1 in s, that means I index of s will remain same. We have to check from I in s equals to t from I plus 1, right? So that's it. And also we have to return this nt minus ns equals to 1. So there can be different scenarios, like first of all, if s is empty, right, then it will not go inside this for loop. Even if both the character, all the characters are same, both string s and t are same, then also this will not return anything. In that case, I have to return this condition. There should be at least this difference, nt minus ns should be equals to 1. Wow. Okay,